And so the key things we need, the first few problems, all they're going to have us look at is those key pieces. So I want to find the x and y intercepts, and then we're doing very similar stuff to what we've been doing, where we're just going to talk about the behavior of the x-intercepts. Does it bounce or cross through the x-intercept? So how do we find an x-intercept? Plug in 0 for y. Excellent. So even if it looks kind of weird like this, you're still just plugging in 0 for y. And so we have 0 equals this x squared minus 3x all over our x squared minus 5. What's my first step? How am I going to try to solve for x? Josh? So we're basically going to try to get rid of this denominator, right? So what do we want to do? Multiply by it. Excellent. So if I multiply both sides by that x squared minus 5, what do we notice happens? It's going to be 0, because 0 times anything is just 0. And so really what you end up seeing is when you find the x-intercept of a rational function, all you need to do is find the 0 of the numerator, because the denominator is going to disappear. Okay, so in this case, now we can factor it out and do the same things we've been doing. So this will be x times x minus 3. And so my two x-intercepts in this case are going to be at 0, 4, 3. Okay, so now we have our two x-intercepts. This is going to be the same way we're going to start any of these graphings later on today as well. Okay, how do I find a y-intercept? Plug in 0 for x. So even if it's weird looking, same idea. So if I plug in 0 for x, we're going to see that y equals 0 minus 0 over 0 minus 5. So we'll see that we have 0 over negative 5, which is 0. Okay, and hopefully that makes sense, because we actually already found an x-intercept at 0, so that should be our x and y-intercept. And so the y-intercept will be at 0, 0 as well. So for those first couple questions, I just want you to talk about what's our behavior. Am I going to bounce at this or go through at these x-intercepts? So should we bounce because of our multiplicity, or should we cut through? We're going to cut through because it's got an odd multiplicity. How about x equals 3? Bounce or cut through? Cut through. Good. So both these, yeah, because it's odd. So in this case, both these have multiplicity of 1. They occur once. And so we know that they're going to cut through in both those cases. If it had an even multiplicity, so if one of our factors was x minus 3 squared, then we would know that it has multiplicity of 2, so it would bounce. All right, so now we're going to take some of this and help us graph these rational functions. So looking at number 37 from our homework. Finding the x-intercept, we're going to plug 0 in for y, which makes the denominator basically disappear. So to find our x-intercept, we're just going to solve for 0 equals x plus 3. So what's my x-intercept? Negative 3. Good. So we have an x-intercept at negative 3 comma 0. Y-intercept, we plug in 0 for x. So for the y-intercept, we'd notice that we end up with 0 plus 3 on top and 0 minus 1 on bottom. So our y-intercept is negative 3 as well. So this will be 0, negative 3. So now we have two coordinate points. And then we want to go ahead and find vertical asymptotes. Anybody remember what vertical asymptotes are and why they occur? It doesn't touch it. Good. So it's going to be a vertical line that the graph never touches. Anybody remember why that happens? Because of the denominator. What don't we like about division? We don't like divided by 0. Excellent. So if I set this denominator equal to 0, I can figure out where I will never touch what x can't be. So what can x not be in this case? 1. So my vertical asymptote is going to occur at x equals 1 in this case. Okay. The last piece we need to figure out is horizontal asymptotes for these rational functions. Horizontal asymptotes are going to occur, or any sort of an asymptote, are things that we approach with division because we'll get towards numbers but never actually reach them. And so what we're going to start to think about is with a horizontal asymptote, our thought process is what's happening as x approaches infinity. So as I go really, really big in the positive direction, or as x approaches negative infinity. So as x goes infinitely large towards the negative direction, am I approaching a number? Okay, so in this particular case, let's think about this. If I had x and towards infinity, we're thinking really big numbers. So if I plugged in 1,000,000 for x, this is going to end up being 1,000,000 plus 3. So this is going to be 1,000,003 basically, over 1,000,000 minus 1, so 999,099, right? What is that number really approaching? It's approaching 1, right? This becomes extremely insignificant. So we're going to really just look at it as 1,000,000 over 1,000,000, and so we're approaching 1. So as we go towards the positive infinity, y is going to approach 1. Let's think about it from the other side. What if we went towards the extreme of negative infinity? So I plug in negative 1,000,000 now, plus 3. So now we're at negative 999,997. Over negative 1,000,000 minus 1. So we're over negative 1,000,001. What am I approaching again? We're approaching 1. Negative 1,000,000 over negative 1,000,000 is approaching 1. So that's how you can find those horizontal asymptotes. As your x value gets really, really big, you really only look at your lead term, the one that's the most powerful, the most dominant, the highest degree, so to speak. And then you go, all right, so what am I approaching? In this case, I'm approaching 1. So now I have 4 pieces of information that will help me graph this. I have an x-intercept at negative 3. I have a y-intercept at negative 3. I have a vertical asymptote at x equals 1, which I always draw my asymptotes with dotted lines so I know I approach them but don't touch them. And then I have a horizontal asymptote at y equals 1. Okay, now the tricky part is how do I graph it from here? I don't know what it's going to look like. I think the easiest way, one, is just type in the calculator. It'll kind of give you a picture so you can see roughly where it's at now that you have the key points. Or hopefully you can kind of get some intuition about this and be like, okay, where's it going to go? So I've got kind of 4 quadrants that I've built, right, with these asymptotes. Let's pretend these are first, second, third, and fourth quadrants. Okay. Where do you think you want to start your graph? Or where do you know points are going to exist for sure? Down in this bottom left one. So this would be kind of a third quadrant, right? So I know I'm never going to actually touch 1, so I'm approaching it. I'm going to cut through the x-axis at that intercept. I'm going to cut through my y-axis at that intercept. And I'll never actually touch x equals 1, so I'm going to disappear off into the forevers that way. Okay. Where do you think you should go next? What's your intuition tell you? Top right is our intuition, right? Here's one thing that's going to confirm it for you. Just like with our x-intercepts and knowing that I'm crossing here, so I'm going to go from the positive world to the negative world because it had multiplicity 1. Same thing happens with your vertical asymptotes. Since this vertical asymptote had multiplicity of 1, so that 0 occurred once, we're going to also cross the x-axis, so to speak. So I'm going to go from the negative up to the positive, so it makes this jump. Okay? And then I know that I'm going to peel off here because I can't ever get there. Hopefully intuition also tells you I don't have any points in this quadrant over here, so I know I should not be graphing in that area because I'll never cross that x-axis to actually reach our asymptote. Cool? So this is kind of a basic one. We only have one vertical asymptote, so it's something that we're a little bit more familiar with. Kind of looks like that 1 over x thing. Okay? So next we're going to take a look at something a little bit more complicated. Now we'll have 2 vertical asymptotes. And this will actually be very similar to the one I give you on the test. So I'm only going to give you one question like this on the test. And it will be very similar to number 43. All right. So same approach here. Let's start with x-intercepts, y-intercepts, vertical asymptotes, identify the horizontal. So in this case, I've got x-intercepts when the numerator is 0. So what we're looking for is 0 equals 2x minus x squared. And so we'll have 0 equals x times 2 minus x. So my two x-intercepts are going to occur at 0 and 2. Y-intercept, we're plugging in 0 for x. So if I plug in zeros for x, we're going to end up with 0 minus 0 over 0 plus 0 minus 5. So this ends up being a 0 over negative 5, which is just 0. Hopefully that's what we expected. Since an x-intercept is 0, your y-intercept is also 0. It's going to go through the origin. We can think about the vertical asymptotes, which is when the denominator is 0. So with our vertical asymptotes, we want 0 to equal the x squared plus 4x minus 5. So from here, you can factor and solve for your two asymptotes. You end up with 0 equals x plus 5 and x minus 1, which tells me my two vertical asymptotes are at x equals negative 5 and at x equals 1. Those are my two vertical asymptotes. And then if we think about the extremes, so now we want to think about the horizontal asymptote. As x approaches positive infinity, we end up with, let's use a million again. You'd end up with 2 million minus a million squared. What's the way bigger number? The million squared part, right? So we can kind of ignore the 2x. And so basically this ends up just being negative million squared. Granted, we'll be able to pull 2 million out of it, but 12 zeros trump 6 zeros any day. Okay, on the bottom, we'll have a million squared plus 4 million minus 5. What's the most important part? The million squared piece. Okay, everything else is just kind of small in comparison. So what number am I approaching? 1. Positive 1 or negative 1?
Negative 1.
Negative 1, because we have the negative million squared over positive million squared. So we're approaching y equals negative 1. Cool. So now I have a horizontal asymptote. I have vertical asymptotes. I've got my x-intercepts. I've got my y-intercepts. The last thing in this particular case, it actually will occur. I probably should have shown it on the last one. We want to know, can I cross a horizontal asymptote? The answer is yes. Vertical asymptotes you'll never cross because it's that division of 0 thing. Because a horizontal asymptote is really just the end behaviors. It's what we're doing in the extremes. The stuff in the middle could actually cross it. So to see if we cross it, we're going to take this value of y and see if it ever exists. So we're going to plug it in for y. When we plug in negative 1 and then multiply both sides by the bottom, we'll see that we get a negative x squared minus 4x minus plus 5 equals 2x minus x squared. So I just substituted in negative 1 for y and then multiplied by the denominator. So if I try to get the x squareds on the same side, we'll add x squared to both sides. That'll cancel. Okay, so plus x squared to both sides makes that disappear. And then if I add 4x to both sides to get my x's together, we'll see that we end up getting 5 equals 6x. So 5 divided by 6 is going to equal our x. So yes, I actually will cross the horizontal asymptote at x equals 5, 6, because the coordinate point 5, 6, comma 1 exists. Does that kind of make sense? That's one of those weird things where you're crossing an asymptote. Huh? Yes, I'm going to give you one very, very similar to this on the test. Crossing the asymptote. Yes, Abby. So the horizontal asymptote, again, I think this is the most confusing because it's kind of the most new piece, is you're looking at the limits kind of. So as x, so in this case, as x approaches a really big number. So I chose 1,000,000 to be my really big number. So, what? 100,000 is a big number too. But I chose 1,000,000. So as x approached 1,000,000, I plugged 1,000,000 in there to see what would happen. So I ended up with negative 1,000,000 over positive 1,000,000 with a little bit of other stuff going on. Because 1,000,000 squared has 12 zeros. So this would end up being 2,000,000 minus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That number is huge, so this doesn't make much of a difference. We kind of ignore it as we get towards the extremes. Yes. The biggest degree, because they increase so much faster. Same idea on the bottom, I'd end up with that huge number with 12 zeros, whatever that number ends up being, plus this little tiny stuff like 4,000,000. Okay. So that number's so much smaller than that we can kind of ignore it. So we're approaching negative 1,000,000 squared over 1,000,000 squared, which is negative 1. That's how we find it. Okay, got it. So for seeing if it crosses the horizontal asymptote, okay? I know some of you are probably getting confused, so our default is to check out and ignore it. But let's see if we can actually work through this. It's true. Okay? So if I know my horizontal asymptote is at y equals negative 1, you take that value, negative 1, and plug it in for y. If you can find an x value for it, which in this case we did, we multiplied both sides by x squared plus 4x minus 5. I multiplied it by the denominator, so I ended up with negative 1 times x squared plus 4x minus 5. That's how I got negative x squared minus 4x plus 5. And then I have the top. Yeah. And then I solve for x, so we see that we actually have it. Now you have all the information to graph. So when we go to look at this graph, you have x-intercepts at 0 and 2. We have vertical asymptotes at negative 5 and positive 1. And then we end up with a horizontal asymptote at negative 1. So now you basically have these 6 quadrants that you're kind of working with. So what's one that you think we should start with? Upper right, upper left, bottom left. You want to usually start in a corner. Upper right because there's a coordinate point. Good, I agree. So we're going to go ahead and I'm going to approach this line but never actually touch it, because that's our horizontal asymptote. And I know, actually one more point we knew, we cross this asymptote at that coordinate point at x equals 5, 6. Sorry, that was the one extra point we found. So I know I'm going to approach it but never touch there. We're going to cross the x-axis at 2, and then we're going to get vertical with it because we're never going to touch the vertical asymptote. The multiplicity of this asymptote is 1. Right, so the vertical asymptote here occurs once, or multiplicity of 1. So I'm going to skip from the top to the bottom. So it's going to be opposite. This also hopefully kind of makes sense because it's going to go through the horizontal asymptote at 5/6, through the x and y axis at 0, 0, and then this will bend back up because I can't come back through anything. I don't have any coordinate points that suggest that.
So why can it go through the...
It goes through here because we already solved for that. Those are the points that existed. And then again, multiplicity of this vertical asymptote at -5 has multiplicity of 1, so I know it's going to go from positive to negative. So we're going to have that jump piece again. And hopefully that makes sense to our intuition because there's no x-intercepts over here, so it's going to bend off before it gets back to the x-axis. So that becomes our graph. You will have one very similar to this on the test. Right now, the horizontal asymptotes and maybe some of the graphing piece doesn't make sense, but hopefully we at least know how to do the x-intercepts, the y-intercepts, and the vertical asymptotes. That'll get you more than half the points on that problem. Okay? The things that we'll need to struggle through a little bit more is figuring out how do we find the horizontal asymptotes and how do I know this picture. Okay? You can also take that and type it in your calculator, and the calculator will give you this picture, so it'll help you fit it as you're doing your drawing later on. Sound good? All right, so that's the graphing piece. I think also with graphing, sometimes it's nice to look at, here's a graph, tell me what the equation is. So there's, the last thing we're going to look at today is working backwards, so to speak. So we're going to have a graph, and we're going to need to identify what the picture is, or what the graph is. Equation. Okay, so something like this. Computer's starting to freak out. Something like number 55. You're going to recognize it has 2 x-intercepts, it has 2 vertical asymptotes, and it has a horizontal asymptote. So we're going to try to work backwards and think about how did we find those things. So how can we work backwards? X-intercepts occur at -1 and +4. How do we find x-intercepts typically? Plug in 0 for y, which made the denominator disappear. So really it was the zeros of the top, right? So what's the top of my equation look like? Excellent. X minus 4 and x plus 1. Right, for our 2 intercepts. Good. So you basically can take the 2 linear factors of your x-intercepts. Now you have the top of your equation. Okay, how do we find the bottom? Or what does the bottom normally give us? The bottom gives us our asymptotes. So if I look here, I see that an asymptote happens at -2 and at +3. So when I go to create the bottom, what am I going to have? X plus 2 and x minus 3. There's the equation of this graph. And we're done. Okay. The back of the book, I think, will show the answer where this is actually multiplied out, but this is all you really need, because this will help you out. Okay. So that's what we're looking for. We're going to try to do some graphing today. Some of it will start as a graph, find the function, and some of it will start as a function, go ahead and find the graph.